Alright guys, we're going to work on the points to remember. Okay, so we want to make sure we use the proper electrode for each welding operation. What does that mean? Well, we need to make sure that we're using the correct current, the correct polarity, and we're choosing an electrode that's appropriate for what we're trying to attempt. Okay, we want to make sure that our arc length is the diameter of the core electrode. So if I'm using an 1/8 inch diameter electrode, it's going to be an 1/8 inch arc length. We want to also make sure that we have a travel speed that's just fast enough to make spaced ripples, but we don't want to go too fast or too slow. Otherwise, we have an inappropriately spaced weld. We want to make sure we have the correct current. Well, come on, guys. If we don't have the correct current, we know we're going to have a problem. Okay. Depth of penetration. This one's really important to remember. Should be 1/3 to 1/2 the total thickness of the weld bead. Okay. Make sure the molten metal from the electrode fuses completely with the base metal. We know that our toe should look nice and smooth. If we're going to have to restart, we want to restart about a 1/2 inch from the front edge and come back into my arc. Now, we want to avoid undercut and overlap by paying attention to how hot or cold it is and our electrode angle. And usually they say, according to the book, quote unquote, we want to use AC rather than DC on jobs that we can use it for. That's not always something that we can do. We also want to make sure that we clean the slag from the weld. We want to make sure that we don't have slag into our weld, otherwise it can make slag inclusions. All right, so what factors allow for a quality weld with proper penetration? Well, we know it. Arc length, amperage, angle, manipulation, and travel speed. What factors must be considered when we select an electrode? Well, we need to think about root opening, joint design, position, and ultimate service use. Okay? How is a crater affected when the arc is too long? Well, if it's too long, we know that it's going to be kind of flat and not right, and we're going to get a lot of spatter. And if it's too short, well, it's just going to be very irregular. When the arc length is too long, what happens to the metal as it melts from the electrode? It just goes everywhere. We're not focusing or directing it in any way. How is it possible to identify a weld that has been made with too long of an arc length? Well, we're going to be able to see it in the weld. It's just not going to look right. There's going to be spatter. Okay. What is likely to happen to the electrode when the arc length is too short? More than likely, you're going to stick it. Okay. What are some electrodes of a weld made with too short of an arc length? It's going to be inconsistent. We're going to see that you have a couple of good ripples, and then it's just not right. And you have a couple of good ripples, and then it's not right. Okay. What are some factors that must be considered when we determine arc length? Okay. Everybody say it. Diameter of the core electrode. In what way does the amount of current affect the weld? All right, current, i.e. resistance, into our material, i.e. heat. How hot is it? Are we burning it? Is it too hot or too cold? What determines travel speed at which an electrode should be moved? Well, here and there, it's kind of user. Some people weld very quickly and it's just fine. Other people, travel a little bit slowly. It's going to also be affected by how hot our weld is, how hot the adjacent areas are, and then what position we're moving in. Sometimes we move a little bit quicker in different positions. What is a crater? A crater is the hole that we make before we fill it. What should be the depth of penetration? 1/2 to 1/3. Okay. What should be done when the crater gets too hot and the base metal has a tendency to run over the surface? We're going to lower it. Okay. We don't want it to run over the surface, otherwise we're going to create overlap or something that just sits on top of our material. How should an electrode be restarted? Well, we're going to strike it in the area that we are going to weld, about a 1/2 inch in front of the crater that we had, and then hook it together and keep on going. What causes undercut? Well, if we have too fast of a travel speed, if our angle is incorrect, if our manipulation is incorrect, or if it's too hot, okay? Now, how can we prevent it? Well, we got to make sure that we have the correct angle, the correct arc length, the correct travel speed, and the correct amperage. Okay. What are ways to prevent arc blow? Well, the first one is change it to AC. That's what the book always says, so we're going to roll with it. Okay. We can move our ground closer. We can backstep. Those are probably the most important ones. How should slag from a weld be removed from a workpiece? Very carefully. Please wear your PPE, and you will scrape your chipping hammer across it, and then you will go and use your wire brush.